So today we are going to talk about a Python script that is used to analyze virtual screening results obtained from Autodock Vina. This script is helpful in fetching the top compounds. For example, when you are doing virtual screening for a protein structure and you have to screen multiple compounds that can be hundreds or thousands, so you obtain the same number of log files, and it's really difficult for you to manually analyze each file for, and then you have to find out which compound has the lowest binding affinity. So this script will help you to fetch top compounds among those hundreds or thousands, and then you can manually analyze for the number of interactions and whatever requirement you have. So hi, this is Muniba Faiza and this is Bioinformatics review. We have actually published an article on this as well. Here you can find the usage, the example, and where it is available. So let's begin with downloading the script, and then we will show you how can you use this script on log files. So you can download this file from our GitHub account of Bioinformatics review under the project VS Analysis, or you can also find it on my personal GitHub account under the same project entitled VS Analysis. So I have downloaded this script here, as you can see, and here is my directory where I have a few log files, around maybe 9 or 10. So this is an old output file. Let's delete it first. Okay, so we have 9 or 10 log files and a VS Analysis Python script. So now what you have to do is open a terminal. It will be better if you use Python 3 in running this script, because if you have Python 2.7 or something as default, so otherwise it will give you an error. So let's run Python 3 and vsanalysis.py. Hit enter. Now it is showing that directory path is detected and there are 9 log files in the current directory. Okay, binding affinities are sorted. Now it is asking enter the number of compounds for which you want to get binding affinities. Since I have 9, so maybe I will need top 5 and enter this number, and okay, now it is showing done. The result is provided in the output.txt file. Let's check the output.txt file. Okay, now my output file is showing the lowest binding affinity at top, and then the second lowest, third lowest, fourth and fifth, and so on, so and so forth. So as you can see, it has, if you see the flavon.txt, yeah, it is showing the first binding affinity. So this script will fetch all the binding affinities for the first pose. Okay, and since it is considered as the ideal pose because of 0 RMSD and other for other reasons, and it is considered the best conformation of the compound within the binding pocket. But you can also consider other factors, for example number of interactions, or whether it is interacting with the binding residues or not. It totally depends on your study. But this script will give you the top compounds that are best fit within your binding pocket. So if you, for example, if you enter another number, let's say I need 7, so let's check the output file again. Now it is again showing you 7. The order is same because the lowest binding affinity is shown by flavon.txt, the compound flavon, and here the HLA Vina.txt is 6.7 and flavanone is -6.6. so that's how you get the results, and you can select the top compound for your further experiments from here. And here is some other points you should note, that your log file, while you're using this script, your log file must contain the word log in its name, And here is a tip for you, that if you include the name of the compound instead of using 1 2 3 4, it will be more presentable, and it will make it easy for you to identify the compound. Otherwise you will have trouble that which compound is that 1 2 3 4. So it depends on you whether you want to include the name of the compound or not, but do include the the term log within your output log files. Okay, so that's all about this script. If you want to read more about it, you can read it here in our article, and it is available on our Bioinformatics review account and Muniba Faiza, my personal account at GitHub. And if you have any query, email me at muniba@bioinformaticsreview.com. And if you have any other query regarding bioinformatics review, you can email us at info@bioinformaticsreview.com. And you can join our community question and answers. You can ask a question, you can join our Telegram channel, Facebook group, Reddit group, and yes, you can also subscribe to our magazine. Here you will find different options for digital access, print and digital, and institutional access subscription. Here you can find different topics which we have covered on our website, and if you have any suggestions, please don't forget to send us at info@bioinformaticsreview.com. So that's all for today, and I hope you know how to use that script. If you have any questions or errors, you can always email me at the given email address. Subscribe to our channel for more such videos, and thank you very much.